Good morning.
Good morning, sir.
Am I audible?
Morning, sir.
Good
Good
morning.
morning, sir.
Yes,
Okay,
Yes, sir.
we'll start. We'll start within 2 minutes. Okay. Is it my screen is visible?
Yes, sir.
yes, yes, sir.
Okay, let us will start. The last time we have already started the CPM and Pert. The CPM part, some part of CPM we already discussed. That is critical path method. How to construct the network diagram. Then after constructing the network diagram, we have to calculate the time estimates of each and every activity, that is the earliest start time, earliest finish time. There are two types of time calculations: the forward pass computations and backward pass computations. So the last time we have discussed the forward pass computations, that is we already calculated the earliest start time, right, and earliest finish time. What is the earliest start time? Try to understand the meaning of this. It is the earliest possible time at which an activity may start, right? The earliest start time is the particular activity may start at this specific period of time. Earliest finish time means the activity which is finished without delay or without violation of a precedence requirements. That means the earliest finish time is the activity which is going to be finished, right, without violation of projects. Calculation of EST and EFT from the following activities. This diagram which already we have drawn, right? I think this diagram is with you. Is it? Diagram is with you? All of you. Do you have a diagram of
Yes, sir.
this?
Yes,
Ah,
sir.
Yes,
same example. Just I will repeat in short. Now here earliest start. Now this diagram, network diagram, consists the number of activities, right? So activity 1 to 2, 1 to 3, 1 to 4, 3 to 5, 2 to 5, 4 to 6. It means that here in the table they have given the activity 1 to 2, it will take a time that is 2. Maybe in days, say for example 2 days. If you want to activity 1 to 3, to complete the activity 1 to 3, the 4 days will be taken. 1 to 4, 3 days will be taken. 2 to 5, only 1 day will take. 3 to 5, 6 days are taken. 4 to 6, 5 days, and 5 to 6, 7 days. So this is the time, estimated time given for each and every activity, and the same is represented in the diagram also. Right? So 1 to 2, 2, 1 to 4, 1 to 3. Now the activity 1 to 2. This is the activity 1 to 2. So this 1 to 2 activity, when it will start this activity, because before 1 to 2 there is no any other activity, so it is just begin. So that means it will start at 0, EST, earliest start time is 0. When this 1 to 2 activity will finish, because the 1 to 2 activity will have a duration that is 2, so after 2 days this activity is going to finish, right? And once the activity 1 to 2 finish, then only activity 2 to 5 will take into place. Are you getting or not? That is why here the duration of this activity plus 0, that is earliest start time, is equal to earliest ES, earliest start time 2. Now 1 to 3 activity. So 1 to 3 activity earliest start time is 0. But when it will finish this 1 to 2 activity, 1 to 3 activity, the 4 plus 0 is equal to 4. So that means 3 to 5 activity will take place, that is at 4th day, right? After completion, immediately after completion of the 1 to 3 activity. Similarly, 1 to 4 activity will take place at earliest start time 3. Now 4 to 6, 4 to 6, when this activity 4 to 6 is started at 3, but when it will finish, right? Because this duration plus this 5 plus 3, 8. But this is not the answer. Why? Because there are many other paths are there are many other ways are there, so which is the maximum time, that time has to be considered. So here 2 to 5, okay, fine. So 2 to 5 means earliest start time is 2, this is 1, 3. But here again 1 to 3 and 3 to 5, this activity is taking 10 days. But to complete 1 to 2 and 2 to 5, this activity taking only 3 days. So 1 to 2 and 2 to 5, this activity has to wait for 7 more days. That is why the maximum time is to be taken, so EST will be the 10. After completing both the activity 5 to 6 will take into place. Otherwise, no. Otherwise, it has to wait. So, after completing the both path, both ways, the 5 to 6 activity will take place. That is, earliest start time is 10, 6 plus 4, which is the maximum. Similarly, to complete the activity 5 to 6 and 4 to 6, 7 and 5 duration is required. So, which is again maximum, 10 plus 7 is 17, and here 3 plus 5 is 18, 8. So again here 9 days the 4 to 6 activity has to wait. Because what is the maximum, that duration is going to be considered. The calculation, the same thing here, I have written earlier start time plus duration. Earlier start time plus duration. Simply I put into the formula. Now calculation of LEFT, earliest finish time. Keep in mind the formulas. In MCQ the formulas are very important. This is the duration for each and every activity, right? Earliest start time just now we have calculated 0.00243, right? The earliest start time plus duration will be the earliest finish time. Finish. By using this formula, it is very easy to work out instead of looking at diagram, right? So earliest start time plus duration will be the earliest finish time. So 0 plus 2, 0 plus 4, 0 plus 3, so on, 10 plus 7 is 17. So this will be the calculation of EFT and EST. Right? Now, once we calculate the EFT and EST is calculated from right to left, right? That is forward computations. Now we have to use left to right, that is backward computations. So in that case, it is called at latest time. Latest time is going to be considered. So calculation of LST by calculation of LFT. Now instead of looking at this table, first of all I will refer this diagram. So diagram will be backward calculations we have to find out now. The EST, earliest start time, so latest finish time will be 17. Earliest start time and latest finish time will be the 17 here. Same. Right? Once the latest finish time is 17, now when this activity will finish, when this 5 to 6 activity, when this activity will finish, LFT, what is the latest finish time of this 5 to 6 activity? So 17 minus duration, 17 minus the 7 duration will be the LF, latest finish time. Similarly here 4 to 6 activity, LF latest finish time is 17, so 17 minus this duration, that is how much? 12. That is how much? 12. Now again similarly here for 1 to 2 activity, what is latest finish time? Latest finish time for this particular activity, latest finish time is 10, so 10 minus 1 will be here how much? 9. Now again for 3 to 5 activity, the latest finish time is 10, right? So again 10 minus this duration will be here how much? 4. 10 minus this duration will be 4, right? Now we have to work out this. Now latest finish time. In forward calculation we have taken the highest one. Now here we have to take the minimum one, right? So 1 to 3 activity, the latest finish time is 4. 1 to 2 activity, the latest finish time is 9, and 1 to 4 activity, latest finish time is 12. Now if you subtract the duration, 1 to 4 duration, that is 12 minus 3, 9. But cannot be. Why? Because the other activities will be overlap. Because earlier start time and latest finish time should be a 0, same. So here 12 minus 3 is 9. Again 9 minus 2 is 7 and 4 minus 4 is 0. So 0 will be considered. Right? The minimum difference we have to consider. Now the same thing I will put into the formula. Same thing I will put into the formula. Calculation of LFT. Say events. I have written here events 6, 5, 4, 3, 2, 1. There are 6 events. And I have written in an increasing order. Right? Sorry, decreasing order. So sixth event LFT total duration is 17. Right? So it is 17 LFT. Now for LFT of 6 minus duration. LFT of 6 is 17. So 17 minus duration of 5th activity, that is this activity. Right? This activity. Right? 5. This activity. 5 to 6 activity. 5th node. So here this is 5. 17 minus 5 is 12. Right? Again LFT of 5th, node 3, node 4, node 2. Each and every node we have to work out this. 17 minus 5 is 12, 10 minus 6 is 4, 10 minus 1 is 9. Just now we calculated. Now here again similarly the 4 minus 4 is 0 has to consider. There are other answers but that we are not going to consider here. Right? So 9 minus 2 7 and 12 minus 3 is 9. But whichever is less only considered. So that is what the LFT calculations. Now once we get an LFT, then simply we have to put into this formula again activity 1 to 2, so on 5 to 6, then durations, then LFT just now which we calculated. Here we have to take the LFT of this, right? And the LST calculation, the formula keep in mind, the LST is equal to latest start time. Right? Latest start time is equal to latest finish time minus duration. So latest finish time is 9, 9 minus 2 duration is 7, 4, 4 minus 4 is 0, 12 minus 3 is 9, 10 minus 1 is 9, 10 minus 6 is 4 and 7 minus 5 is 12 and 17 minus 7 is 10. This is what the LST, latest start time, maximum late, that is this latest time is calculated. Similarly, now you work out by using the diagram or this formula. Note down this table. Note down this example. Example 2. Calculate the earliest start time, earliest finish time, latest start time and latest finish time from the following activities. Come on, fast. Note down this. Note down this. First of all, before we going to calculate the time estimates, we have to construct the network diagram. Basic need is to construct the network diagram. Note down the example and draw the network diagram. Time calculation is very simple. While drawing the diagrams, only we have to apply little bit logic. Once it is over, you tell me. You have taken this example. For practice of this example, you will come to know the how to work out the all time estimates. Is it over? Have you taken the example? Yes or no?
Done, sir. Done, sir.
Okay, you do one thing. Now you calculate the network diagram. Chalo, come on, fast. Network diagram. You have to draw the network diagram. Draw the network diagram. A, B, C. Now here there is no predecessors activity. It means that the A, B, C, these are the parallel activities, starting activities, right? Parallelly starting activities. From A, two activities have been started, that is D and E. From D only one activity is started, that is F. From C only one activity is started. From D only one activity is started, but from E and F, the I activity is started. Right? You draw the network diagram. Little bit logic we have to apply. Nothing is complicated. Come on. Let it be wrong, doesn't matter. All of you try. I will show you the result. Don't worry. What? Anyone else completed? Anybody has drawn the diagram? Anybody has drawn the diagram? Let it be wrong, doesn't matter. Anyone has completed? Yes? Come on, tell me. Have you completed? At least you say yes or no. Hmm?
No, sir.
Why? Very simple, little wrong. Sneha, have you completed? I will explain. I will explain. I will give you 5 more minutes. Say A, B, C. The parallel activities A, B, C. From A node, the D node is created. From A node, two nodes have been created, D and E. From B and C, F and G is created. And from D, H is created. And from E and F, I is created. Very simple. Come on, anyone, can you share me the screen? Doesn't matter. Let it be wrong. We'll correct it, no problem. Hmm? Nobody is ready to share. Huh? Your logic is very poor. See, I will show you here. This is the diagram. Activity, this is A activity, that is 1 to 2 I have given name, right? This is B activity, I have given 1 to 3 name, and this is C activity, I have given 1 to 4 name, right? First of all, you try to understand the diagram. Don't take down anything, right? You work out on your own. So A, B and C. But note the logic is the which activity is to be where place location, appropriate location, right? Now from A activity, ABC is over, right? A, B, C. These are the three activities which I have shown here. This is A, right? 1 to 2. This is B, 1 to 3, and this is C, 1 to 4, right? Now from A node, two different activities have been created. From A node, two different activities have been created. That means from A activity, from this A 1 to 2 A activity, two different activities have been created. That is what this D and E. So from this 1 to 2 activity, two different activities, that is 2 to 5 and 2 to 6. That is D and E activity. That is what D and E activity. Is it? Are you getting or not? Are you with me? Are you getting?
Yes, sir.
Ah. Now, next. Is it clear? A, B, C. From A, D and E is created. Now B, F is created. From B, F activity is created. This is B, and from B, this is the F activity I connected here. Why I connected here F activity? Again from F and E. Again from E and F and A, the new activity is created. That is why I connected there. So from B, F activity is generated. From C, G activity is generated. From C, where is C? This. From C, the G activity is generated. This is the G activity, right? This is the G activity. Now, from C, G activity, and from D, H activity. From D, where is D? This is D. From D, from this D activity, the H activity is generated. Because there is no further activity, so I have to end the project. I have to end the project. So all activities I am taking together here, right? So from D, H activity created. From E and F, what is E? This is E and this is F. So from this node, so this activity is created, What is that activity? I activity is created, right? So here, this is the I activity is created. Okay, now I activity is created, finish. So what to do? This is A activity, this is B activity, this is C activity. From this A activity, two different activities are created. So that is D and E. Again, from C activity, J activity is created. From B activity, F activity is created. And from F and E, the I activity is created. From D activity, H activity is created. And from C activity, J activity is created. Finish. Is it understand? Construction of network diagram. MCQ, the question will not be asked, but you should know how to construct the network diagram. Because if you properly construct the network diagram, that means from this diagram you come to know which activity and where it will take place. What is the start of activity, what is the end of activity, what is the head event, what is the tail event, which is the predecessor activity, which is the successor activity. So this concept will be clear from this diagram, right? Now, while working the time estimate, shall I move to next? Shall we calculate the time estimates? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, earliest start time. As I said, the earliest time at the beginning it should be 0. So this is 0. Right? To finish this 1 to 3 activity here, 0 plus this duration 7. Right? Will be the earliest start time 7. Right? Now again, here for this particular activity, 0 plus this duration is 6. So 0 plus 6. Again, for 1 to 4 activity, duration is 4. So 0 plus 4, ES is 4. Only ES will work out first. Now, for this particular activity, the earliest start time is, right? Earliest start time is, that is, how much? Because this is 7 plus duration, right? This 7 plus duration, that is 4. How much is equal to 11, right? 11. But I cannot start at 11. Why? Because still here 1 to 2 and 2 to 6 activity is in progress. So for 1 to 2 activity, 0 plus 6 and this 6 plus 7. This 6 plus 7. Right? Earlier start time is 6 for 1 to 2 activity. So this 6 plus duration of this activity, 1 to 6 activity, that is 7. So this 8 duration is 30. So if I follow this path, the 13 days are required. If I follow this path, 11 days are required. So I cannot start immediately after completing this 1, 3 and 6 because here this activity is still not completed. So I cannot start the next activity, that is 6th activity. Right? So therefore here I have to wait for, right, how many days? 2 more days. So that is why earlier start time 6 plus 7 is 30. Similarly here, earlier start time is 6 and duration is 3, that is 9. Fine. Now here, earliest start time, this is 30 or this is 9 and this is 4. So if you add the duration, 4 plus 2, 6, this is the first answer. Here 9 plus 5 is 14, second answer, and 13 plus 3 is 16. So which is the highest? 16 is highest, so 16 has to be considered because we cannot start as unless the previous activity complete. Now similarly, latest finish time, LF, LFT, 16. 16 minus duration, 3 will be the 30. Now again, 16 minus duration 5 will be the 11. Again, 16 minus the duration 2 will be the 40. Right? Similarly here, 11 minus duration 3. Right? 11 minus duration 3. How much? 8. But here 6. Why 6? Because this 13 minus 7 is 6. Right? So whichever is less. The difference of this is 8 and the difference of this is 7. So this is less. That is why here I have taken 7. Now similarly, length is equal to 9. The 13 minus duration is 4 is 9. Again, this 9 minus duration is 7. 2. But I cannot take. Why? Because it has to be 0. It has to be 0. So therefore, again, this 6 minus 6, right? This 6 minus 6 duration will be 0, right? 14 minus 4 is 10. No. So whichever is less, we have to take for backward pass calculations. Same calculations we can present in the tabular format, right? So whatever I have calculated here, the same table you generate. With the help of table, you should calculate on your own so that you understand, you clear the more things. Now the next time calculation is determination of float and slack time. The concept we will discuss here, right? Because in the formula is given the float and slack time. The float and slack time is the idle time of an activity and event, right? Of a particular activity and a event. So float means the idle, means the how many days the activity will be idle, how much time the activity will be on hold position. So that is called a float and slack time. Float means the amount of time by which the particular activity can be delayed. Keep in mind the meaning, right? Float means the amount of time the particular activity can be delayed without changing the project duration. Without changing the project duration, right? In simple words, float is defined as the difference between the latest and earliest activity time, and slack is defined as the difference between the latest and earliest event time. See again, sometimes they may ask the difference. In case of the float, the difference between the latest and earliest activity time, right? Activity time, but slack is the difference between the latest and earliest event time. So activity difference of activity time denoted by float, and difference between the event time is denoted by the slack, right? See, this is between the latest earliest event time, activity and event. This is important. Activity, difference between the activity and difference between the float. Both concepts are different, right? And slack time is the difference between the early event. This is event. Now, formula here we are using the slack. How slack is calculated? The slack is equal to latest time event minus earliest time event. Slack formula to calculate the slack. Keep in mind the examination this may be asked for MCQ question. Slack is equal to latest time event minus earliest time event. Right? The basic difference between the slack and float is the slack is used for event and float is used for activities. Right? The slack is used for event and float is used for activity. Both terms are separately used. There are three types of floats are there. First is total float. It means that the amount of time by which the completion of activity could be delayed, amount of time, total amount of time, beyond the earliest expected completion time without increasing the overall project duration. Let us keep in mind only formula, right? The total float means again the activity, the complete type of activity, completion of activity could be delayed. But the formula is total float is equal to latest start time minus earliest start time, which we already calculated in the diagram, right? Simply we have to take that figures and find out the difference of this, so it will give the total float. So whatever calculations, float calculations we are performing, we need the base of the earliest start time, latest start time, earliest finish time and latest finish time, and that calculation is already completed by using the previous example. Or otherwise the one more formula is there, separate, latest finish time minus earliest finish time, right? So both formulas you keep in mind, both way we can work out the total float, both way we can work out the total float. While computing the total float, the value of any activity may be negative. That means the float answer may come in negative, may be zero or may be positive. The meaning of this is, keep in mind, these are three possibilities of answer. Negative means the resources are inadequate and activity may not finish in time. Keep in mind, negative means that it means resources are inadequate. There is no resources are available. Resources are insufficient. That is why the activity may not finish in time. It is not the fault of the system, right? Because due to some inadequacy of resources, the activity is not going to be finished, then it will come into the negative. Zero, it means resources just sufficient to complete the activity, right? Resources are just sufficient. Resources are just sufficient. That is, no excess material, no excess raw material, no excess inventory is required here, right? How much quantity, only that much raw material is there. That is like that. How much duration, that much period is required, right? Suppose 5 days are there, so only 5 days are required, right? 5 activities, 5 days, like that. No any other extra resources are available, so it is zero. Positive, it means resources are available excess. If the answer of a total float is, it means that the resources are excess. So again, if excess resources, it impact on the cost. Again, it impact on the project total cost. Total cost is going to be increased if the resources are more or excess available. Activity can be delayed by so much period, right? It means the resources are available excess, that is activity can be delayed by so much period, because if an earlier activity, previous activity finished, then only the next activity will take place. Free float, it is a portion of total float within which an activity can be changed or manipulated without influencing the float of next or subsequent activity. It is computed subtracting the head event slash, that is difference from the total float. So the formula we have to keep in mind, the free float is equal to earliest event time of the head event minus earliest time of preceding head event. The head event, right? The head and tail event. Diagrammatically I have shown. This is the head event and this is the tail event, right? Now, independent float. The independent float is calculated to free float minus tail event slab, and it is also part of a total float. It is also part of a total float, which an activity can be delayed for start without affecting the float of preceding activity. It is computed by deducting the tail event slab from total float. Thus, it provides a measure of variation starting from job without. Okay, just again, it is a float, means the idle time, right? Why? Due to the resources. And how it is to be calculated? free float minus tail event slack. So all these are the three floats. That is the idle, idle time, delay time, right? Not idle, it is a delay time, right? Situation is different. Sometimes it is negative, sometimes it is zero, sometimes it is positive, right? So these are the formulas you have to keep in mind. What are the different types of floats? You have to keep it in mind. When LFT and LST, this formula. Only this much theory component is available in CPM. This is the completion of CPM. You can refer these notes to work out some more examples, right? Then after this CPM, we will start the part. I will share you this file, right? For theory purpose, you can refer and you can practice the problems on your own. The same problem, if you work out, you will understand. Problems are not very big. Just put into the formula value, you will get the values. Any doubt in case of CPM?
No, sir.
So shall I move to the next concept, that is the
Yes, sir.
Pert concept. Pert. Both file I will share you because complete solved examples are there. So this is the, here I have calculated, right? Simply put in the formula or from diagram, you get this figure. Because this much big questions or problems will not be asked in the examination. What is negative, what is positive, what is zero, then what is float, what is total float, what is independent float, what is head event, what is tail event, what is free float, what is independent float, like that. What is earliest start time, what is earliest finish time, or their formulas. So such kind of things are expected. Now the critical path, we have already seen that. What are the critical path? Note down the meaning of the critical path. The critical path means the longest path. Keep in mind, the examination they may ask what is critical path. Most frequently asked questions. The critical path means the longest path. After determining the earliest and latest scheduled time for various activities, we proceed to calculate the minimum time required for the completion of the whole project. For this, we have analyzed the network and determined the critical path. So now the critical path means the path which is the longest path. I will show you here in diagram. So this is the diagram. Now in order to complete this project, right? So this is the start point and this is the end point. Look at the diagram, right? Try to understand the concept of critical path because this is most frequently asked question. Critical path. I will explain this. Now this is the start point and this is the end point of the diagram, right? Now here, how many ways we can complete the project? How many paths are there? There are three paths. The first path is 1 to 4, 4 to 6. So 1 to 4 and 4 to 6 this path. What is the duration? 1 to 4 duration is 3 plus 4 to 5 duration is 5. So 3 plus 5 is equal to 8 duration. Second path 1 to 2, 2 to 5 and 5 to 6. So this is here I have written 1 to 2, 2 to 5 and 5 to 6. Now 1 to 2 duration is 2, 2 to 5 duration is 1, that is 2 plus 1, 3 duration, and 5 to 7 is 7. So total duration is required if you want to follow this particular path, that is 1 to 2, 2 to 5 and 5 to 6. That is duration 10 is required, right? Now again one more path is there, right, to complete the project. Say these are the possibilities, Now 1 to 3, 3 to 5 and 5 to 6. Right? 1 to 3 and 3 to 5 and 5 to 6. Now here 1 to 3 duration is 4, 3 to 6 duration is 6, that is 10, plus 5 to 6 duration is 7, that is 17. So this 17 is the critical path. This is your answer. Why the longest path is called as a critical path? Because if you consider the smallest path, if you consider the smallest path, so there is a probability to overlap the activities. There is a probability to overlap the each and every activity, and that overlapping in the network project is not permitted. Why not permitted? Because until unless finish the first activity, we cannot start the next activity. That is why we have to wait for that particular time. So that is why here the latest time is called as the latest time, or the longest time is called as a critical path. Because if you follow this critical path, no activity is overlap. No activity is overlap. Very systematic. After completion of first activity, the second activity will take place in the project. That is why here the longest period is to be considered in case of critical path. Don't say it is the best path, 8. No, it is not the best path. Why? Because some of the activities are going to be overlapping. Some of the activities are going to be overlapping, and that is not permitted, because unless complete the first activity, cannot start the next activity, because next activity depends upon the first activity, previous activity. So this is called a critical path method. Right? Now I will share you this after completion of Pert. Pert will finish the Pert. One more lecture is required for finishing the Pert. Yes, one more lecture. So next lecture I will finish the Pert. Right? Now next who is having lecture? Next lecture is who is having next lecture? Come on, tell me. Which is next lecture? You don't know next lecture? अरे लेक्चर कोणाला आहे पुढचं?
Sir, corporate governance, sir.
Corporate governance. Right? So shall I continue and finish this part?
Yes, sir.
Come on.
Yes, sir.
Okay. I will finish this part. I will take the Sachin sir. Sachin भी गया तो continue करता. Okay, as compared to CPM, the part is very easiest method, right? We always seen the difference between the PERT and CPM. Carefully you read the work out the difference, right? Because from difference so many questions may arise. PERT was developed in the 1956-58 by the research team for planning. As I said, the PERT is used for the research purpose, right? PERT is used for the research purpose, and it is developed in the year 56 to 58, right? For planning, scheduling and controlling. Again, the aim, the goal of the PERT is also the same as we discussed in CPM. To plan the activity, you can schedule the activity by drawing the network diagram, and to control the activity. Right? So this is the Navy's Polaris missile program. It is called as Navy's Polaris missile program. Since 1958, this technique has provided to be helpful for all projects where uncertainty exists in the matter of time or duration. Means wherever the uncertainty, this particular system, this particular technique is used. CPM technique is applicable where activity duration can be estimated from experiences of past historical records and work study technique. In a CPM, it is estimated the each and activity, how much time is to be taken by using an experience of a person or a past historical data. Past historical data. But in Pert, no, it is not like that. We should have to calculate properly. CPM is unable to or incapable of handling uncertainty in timing. Right? Comparatively, CPM is not unable or incapable of handling uncertainty in timing, but PERT is more relevant. PERT is more relevant for handling such a project which have a great deal of uncertainty associated with time. Pessimistic time and most likely time. Only these three time durations are available in PERT. What is the optimistic time? So the meaning of optimistic time is this is the estimate of the shortest possible time in which an activity can be completed under ideal conditions. And it is denoted, usually it is denoted or estimated by a TO. So keep in mind the optimistic time means what? The shortest possible time. That's all. Optimistic time is the shortest possible time. Pessimistic time, this is the maximum possible time it could take to accomplish the job. This is the maximum accomplished time. So this is the minimum time, this is the maximum time. Right? And it represents the longest time the activity could take if everything goes well. Pessimist time is the longest time, optimist time it is shortest possible time. And it is denoted by TP. Notation is TP is used. And what is most likely time? The time between two time, that is optimistic and pessimistic. This is the time which lies between the optimistic and pessimistic time. Right? This is the time between the optimistic and pessimistic time. It is the most probable time which an activity will take. It is the most probable time because neither low or high time. It is the time between the highest and the lowest. It assures that things go in a normal way with a few setbacks. Very few setbacks are considered here, otherwise everything goes well in a project. And it is also denoted by TM. It is also denoted by TM, that is the most likely time. So these are the notations TO, TP and TM, right? For the optimistic time, pessimistic time and most likely time. Calculation of expected time. Now here by using this particular time, yes, these are the three different times we have given. But from these three different times, we have to calculate the expected time, how much time to be expected to complete the project, right? So it is to be calculated by using this formula. So it is the average time. What is this? This is the average time that an activity will take if it was to be repeated on large number of times, and it's based on the assumption that the activity time follow beta distribution calculations. So forget about the beta distribution calculation, right? It is a probability distribution. Name of that probability distribution is beta. It is not in your syllabus, but keep in mind the beta distribution is used for the PERT expected time calculation, and TE is the notation which is denoted to calculate the expected time, TE, expected time. So expected time is equal to TO plus 4TM plus TP divided by 6. This is the standard formula. This is the standard formula. Keep in mind the formula for calculating the expected time by using PERT. This is the standard formula which is used, right? Now, activity variance. What do you mean by activity variance? The beta distribution is assumed for estimate, and Pert analysis have found that the beta distribution curve happens to give a fairly satisfactory result for most of the activity. Now here, actually, beta distribution and variance, these are the concept of statistics. See, basically in a variance what happens, if a graph, bell-shaped graph, right, maybe one-tail distribution or two-tail distribution, means left tail distribution or right tail distribution or center distribution, right? But it is not in the syllabus. Let us ignore this. But try to understand the concept of an variation. Variance. Variation means if there is a high value, means if there is a low value, means there is a no variation. That means if there is a low value, that means the project is completed within a less period of time. If there is a high variation, the project will be completed within a high. It will take. It is not an appropriate. That means depend upon the variation, depend upon this variation, the values project, whether project is to be accepted or whether it is to be continued or rejected or stopped, the decision will be taken. So such variation is calculated, again variation denoted by this standard deviation is equal to TP, right? TP minus TO, pessimistic time minus optimistic time divided by standard deviation, which is calculated, and variance is equal to standard deviation square is equal to, variance means the standard deviation, square of the standard deviation, TP minus TO divided by 6 raised to 2, right? So keep in mind here the important thing is I will highlight the three different types to be estimated in part, that is optimistic time, pessimistic time, and most likely time. Calculations of expected time. This is the formula which is used to calculate the time. Now again the variation, standard deviation and variation is calculated. The SD is calculated by using TP minus TO divided by standard deviation, and variance is equal, this is not 6, right, this is 6, this is 6. Standard deviation is equal to TP minus TO divided by 6, right, and variation is equal to TP minus TO divided by 6 raised to 2. So the power of standard deviation, square of standard deviation will be the variation. Steps in solution of Pert problem, right? First of all, we have to calculate the expected duration and variance for each and every activity. What is to be calculated first? The expected duration and variance for each and every activity. Draw a project network based upon the expected duration of the activity and find out the total expected duration of the project, find the critical activities and critical path, and find the standard deviation of the project. Right? The standard deviation of the project is, this is the formula. The project has the, now note down the example. The project has the following activity, estimated duration in days. The very simple example is there. Note down this example. Come on, too fast. I will explain this example. From this example you will understand. So always in case of Pert, these three different types of times are given. They are given times. Simply we have to put in the formula and work out. Activity, these are the activity. This is the optimistic time, this is the most likely time, and this is the pessimistic time. Note down the example. Come on, fast. I'll give you 5 minutes. Once it is completed, you tell me. Done. Come on. We've completed. We note down the example. Come on, keep on
Done,
interacting
sir.
me.
Yes, sir.
All of you. All of you. Can I go for solution? Can I proceed solution?
Yes, sir.
Yes, sir.
Okay. Now, say I will explain this again. Example: the project has the following activities. These are the activities: 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, and 5 to 6. These are the different times given. That is optimistic time, most likely time, and pessimistic time. And all these time estimation is given in the days. They have clearly mentioned. So now we have to find out. What is to find out? The expected duration of each activity. Expected duration of each and every activity. Then next we have to find out to find the variation of each activity. Variance. Just now we have discussed the formula. Simply we have to use the formula. Right? Find the variance of activities of critical path and standard deviation. We have to now decide the critical path. What is the critical path? Critical path is the longest path. Right? We have to decide the critical path, and of that critical path we have to find out the variance and standard deviation. Right? Now solution. Okay. You make a column here. You make a column here. I will insert one column here. What is to be calculated now? Expected time, TE. You have to calculate TE. What is the formula to calculate TE? Come on, put into the formula here. T is equal to total optimistic time plus 4Tm plus TP. Right? Formula is optimistic time. What is optimistic time? 2. Right? Plus 4. What is Tm? Is 5. Right? Plus TP, that is 8. Right? So this divided by 6, 2 plus 20 plus 8 divided by 6 is equal to 30 divided by 6 is equal to 5. Have you understood? This is the TE. 2 plus 4 TO plus 4 TM plus TP divided by 6. Simply you put these values into the formula and work out. Come on, do fast and tell me the final answer. Here one example I have shown. Come on. Next, tell me, anyone? Work out this now. Put into the formula, very simple. Next, 4 plus 4 multiplies the 10 plus 16 divided by 6 will be this. Again here 1 plus 4 multiplies the 7 plus 13 divided by 6 will be here. Right? Again 8 plus 4 multiplies the 8 plus 11 will be divided by 6 will be here. Come on, work out. One sample is given here. Same thing we have to work out each and every activity. Do fast. Are you calculating? Yes or no?
Yes, sir.
Yes, please, please. Do fast. Do fast. Very simple calculation. Once it is over, you tell me. Over. Only T calculate. Don't calculate variance. One by one will go. Is it over? Yes or no? Come on, tell me. Hello. हाँ बोले. हाँ. हाँ हाँ. आपल्याला काही रूल फॉलो रूल डाउन करत नाही. हाँ, yes, it is over. Tell me, come on, tell me the answer. 1, 2, 3 actually, हाँ.
10, sir.
10. Next, 1 to 4 activity. 7. 1, 2 to 5 activity.
8.5.
8.7.
5.
2.
5. 8.
8. Next, 4 to 6.
9.
9. Next, 5 to 6. How much?
7.
Is it correct? All agree? This is?
7.
7, sir.
Okay, all got it? Now one
Yes,
more
sir.
column left. Okay. One more column will insert here. Right? And next calculations, variance we have to calculate for each activity. Right? Come on. Tell me. Variance we have to calculate. Variance square direct. Variance we have to calculate. Do calculations. Yes. TP minus TO divided by 6 raised to 2. Come on, fast. Do the calculations. TP minus TO divided by 6 raised to 2. Variance. I will remove this because I don't want this now. Formula, let it be. Formula only I will keep here. And this table, entire table I will remove. But there only I have calculated. No? Okay. Chalo, tell me. Over. Figures. Variance. TP minus TO divided by 6 raised to 2. That's all, finish. Come on, tell me the values. No, I don't have any value. Come on. Have you calculated? Come on, fast. All of you, are you doing calculations? Yes or no? Keep on iterating, please.
Yes, sir.
Over calculations. Calculations are over. झालेला सांगा तरी काय किती वेळ होत हा टेल मी चलो बोलिए 1 to 2 how much TP minus TO TP is how much 8 minus TO is how much 2 6 6 divided by 6 is 1 1 raised to 1 is how much 1 only am I right yes or no
Yes, sir.
Yes, sir.
then 16 minus 4 is 12. 12 minus 6 is 2. 2 raised to how much? 4.
4.
Am I right? केले ना कॅल्क्युलेट सांगा
Yes, sir.
की मला परत सांगा ना मग 1 to 4 ला किती येत आहे
4, sir.
1 to 4 1 to 4 activity how much
4,
13
sir. 4.
minus 1 is 4. Right, 13 minus 1
4,
is
sir.
4. Saga, पुढं. 11 minus 8. किती येत आहे? 3. 3 minus 6. पॉइंट मध्ये येते. किती येत आहे? How much?
2.5, sir.
2.5.
5.
Next, which activity? 3 to 5. How much?
4, sir.
4. Next. Come on, next activity. 2 minus
1,
6.
sir. 1.
6. Calculate करत ना. 10 minus 4. 6. 6 minus.
1, sir.
Okay, now draw the diagram. 1 to 2, 1 to 3, 1 to 4 activity. From 1 to 2, again from 2, 2 to 5. From 3, 3 to 5. From 4, 4 to 5. Right? And see the diagram. 1 to 2, 1 to 3, 1 to 4. Right? From 2 and 3, from 2 and 3, right? 5. So from 2 and 3, what is 5? Right? The next, from 4 and 5, 6. From 4 and 5, 6. Finish. 4 and 5, 6. Finish. Right? Draw the diagram this. Come on, fast. Person, draw the diagram. Come on, fast. Have you drawn the diagram? Yes or no? See, are you with me?
Yes, sir.
Come on.
Yes,
You
sir.
draw the diagram. Diagram is, have you drawn, you understand the diagram? Because if it is given like this activity 1 to 2, 1 to 3, start and end point, then it's very easy to draw the activity. Right? Little bit logic you apply, you will come to know. Now, this is the duration. Now, how many paths are this? Is 1 is the start point and 6 is the end point. How many paths are there? First of all, find out the path, total number of paths, right? Say, first path is 1 to 3, 3 to 5, and 5 to 6. So 1 to 3 duration is 10, 3 to 5 duration is 8, and 5 to 6 duration is 7, 25. Second path, 1 to 2, 2 to 5, and 5 to 6. 1 to 2 duration is 5, 2 to 5 duration is 8.5, right? So 8.5, how much? 13.5, and this is 7, that is 20.5. The next part is 1 to 4 and 4 to 6 direct, so 7 plus 9 is 16. So what these are the three different paths. So out of these three different paths, which is the longest path, the first path is the longest path. So that is called a critical path. So here the critical path is double shaded. 1 to 3, 3 to 5, and 5 to 6 is the would be the critical path. Right? Now after this we can find out the variance for the critical activity. What is the critical activity? Critical path activities 1 to 3, 3 to 5, and 5 to 6. These are the critical activities. That is critical activity 1 to 3, 3 to 5, and 5 to 6. So for critical activity, variance of the critical activity will be 4 plus 4 plus 1. Right? So from where is variance? Variance is here. Right? Variance is here. So for 1 to 3 and 3 to 5, 1 to 3, 1 to 3, 4, 3 to 5 is 4, and 5 to 6 is 1. That is 4 plus 4 plus 1. And you understand from where I have taken this 4 plus 4 plus 1? From this table, right? The variance, this of the particular activity, that is activity 1 to 3, right? Then 3 to 5 and 5 to 6, the variance I have taken from table. Now the standard deviation is equal to square root of variance. So this is 4 plus 4 is 1, right? And that is 9. So square root of 9 will be the 3. If you calculate the square root of 9, so it will be the answer 3. So standard deviation of this critical path activity will be 3, right? Critical path activity will be 3. Now here in the problem, expected time we calculated TE by using this formula, whereas we for each and every activity we calculated by using this formula, and the critical path and its standard deviation is calculated for using this formula. Standard deviation is square root of variance. Understand?
Yes, sir.
Okay, so this is what the Pert performance evaluation and review technique. Nothing more than this, right? So you go through the theory component as well as the problems, right? You try to work out the problems, whatever I'm sending to you, the same problem you work out, right? And try to understand the different time estimation, calculation of time estimations, cost estimations, right? Standard deviation, and the appropriate definitions. So this was a big topic. So I think this was just sufficient for examination point of view. But thoroughly you try to understand the concept. They may ask any questions on this. Is it clear? So tomorrow I'll start with the fresh topic. Right? If you are any difficulties, doubts, you can ask me. Please. Otherwise, we'll stop here. Any doubts? Any difficulties? Please.
No, sir.
No doubt.
No, sir.
Okay. Chalo, all the best. We'll leave the meeting. Tomorrow I'll continue with the fresh topic.
सर हेलो
काय झालं तेजस?
Sir is left.
काही नाही
कॉल कर तेजस.
ते सबमिट काय करायचं ते हा काय
कॉल
म्हणतोय?
करून विचार ना.
कोण कॉल करेल एवढं
विचार